Hey guys, welcome to another exciting edition of College Algebra, or algebra taught to me in college because I didn't like my high school teacher. Anyway, so whatever you want to call it. We're ready to roll here with chapter 1. The first section here in chapter 1 is just about the basics of graphing and using your graphing calculator. Remember, for our college algebra class and subsequent classes, pre-calc and calc 1, a graphing calculator is required. It is an expected tool that you know how to use, and most of you guys have had experience with that up until now, but we're going to spend a little bit of time today just talking and reminding you of what graphs look like, how they work, and how to use your calculator. Okay, so that's what this is about. We're going to go through this process real quickly and talk about some basics of graphing. Remember that the rectangular coordinate system, sometimes called the Cartesian coordinate system, has an x-axis and a y-axis. The x-axis is horizontal, the y-axis is vertical, and every single point on here, all right, has an address, and the address is, you have to think of each of these grid lines kind of like the roads. Okay, so how we get here is we go over to the right 3, and that's a positive direction to the right, and then we go up 5. That's also a positive direction. Up is positive, right is positive. And so this is the address 3, 5, because you go to the right 3 and up 5. The x comes first and the y comes second. X is left and right, y is up and down. The point in the middle is 0, 0. Okay, that's called the origin. And it's alphabetical, right? X comes first, then y. X comes before y in the alphabet. X comes before y on the Cartesian coordinate system. Okay, so they give you a couple of examples here, plotting the points. Here's the point -2, 4, +4, to give you an example of that. All right, here's the point +4, -2. Okay, and again, for me, my preference is you don't have to label every single line, but my preference is that you do label each individual point so that you know where you are, and that way, if you have points that are fractions or something like that, then I know where you are. Okay, so that's just kind of my personal preference, but if these grid lines are labeled, then that's great. I do recommend using graph paper. Obviously, you're not going to turn a lot of things in directly to me, but you're going to take pictures of things for your work, and so if you're graphing and doing things like that, having some graph paper is handy. You can make your own graph paper by just putting a table in Word and then printing it out. I do that all the time. But I also picked up a thing of graph paper. So, you know, whatever you need, it's not required, but just to make it a little bit easier for you, sometimes having graph paper is nice. All right. And then when you have an equation in 2 variables, that's when a graph makes sense, because a graph is basically a picture of this equation. This equation is a relationship between x's and y's. If you choose a value for x and you plug it in, you'll get a value for y, and that gives you a point. So as example, for that, if x equals 1, then y is equal to what? It's equal to 4 minus 1 squared. This is a formula for y. 1 squared is 1, 4 minus 1 is 3. And so what that means is the point 1, 3 is it's a point on the graph right, of y equals 4 minus x squared. Now, we're not going to graph things right now. We're going to spend some time later in chapters 2 and 3 on the specifics of graphing. So don't worry about the actual graphing of this equation right now, because this is a parabola and we're going to have to go about doing that. But just understanding the relationship that when x equals 1, y equals 3, that means this point is on this graph, because when you plug in 1 and 3, this equation is true. So a point on the graph equates to a time where the equation is true. If you pick another point and you plug it in and that's not true, that means that point is not on the line. It's not on the curve. It's not on the graph. So what we are going to talk a little bit about, however, is how to use your calculator. All right, so I'm going to pull up a picture of a calculator. This is what a TI-84 looks like. Obviously not exactly, but this is how we do the graphing on a TI-84. You go to this y equals. Make sure that none of these plot guys are highlighted. If any of these plot guys are highlighted, you have to go up there, and you have to click on it and turn it off. Okay, so but mine's not on, so that's good. So I'm going to graph that equation that they just gave us, y equals 4 minus x squared. So the x variables right here, xt, theta, n, these are the variables. And then if you want to get squared, you push this button, or, right, or you could write it as 4 minus x and then use this caret button. This is how you do other powers, right, more than 2, and plug a 2 up there. But then when you do, make sure you come down so you don't put everything else up in the exponent. Okay, so y equals 4 minus x squared, enter. All right, and then here's one of the biggest things about plotting a graph, right? If I just go to graph right now, I might or might not see it. So you need to go to your window and select approximately where you think you're going to be. And most of the time the window starts with negative 10 to 10, negative 10 to 10, and that's probably fine for many of your graphs. But for some graphs, especially if you go to graph and you don't see it, right? So if I go to graph, here's my picture, but that may or may not really be enough of the graph for me. So I may need to zoom in. I may need to change my window. All right, so I want to change my window maybe from negative 10 to negative 5 to 5. But I can't use this minus sign. I have to use this minus sign. Okay, make sure you use the negative sign, not the subtraction sign. So I'm going from negative 5 to 5. All right, and then again from negative 5, negative sign, 5 to 5. Okay, and so now I'm going to graph that, and you'll see the graph looks a little bit different because it's more zoomed in because I changed the graph window. And so there's a couple of other things you can do. Again, you can zoom, you can trace, you can find out where two places intersect. I'm not going to go into a whole bunch of stuff right now. I will gladly try to show you some other things as we get closer throughout the semester. As we go through it, I'll show you how your calculator can help you. Your calculator, guys, is a tool. It is not the answer. Okay, it is not, what I mean by that is it is not going to get you through algebra class to have a calculator. You've got to know what you're doing and then let the calculator help you. Let the calculator check your answer, but the calculator cannot save you if you don't understand what you're doing. So my suggestion is you do need to know how to use the calculator, but if you're relying on the calculator to do the work for you, you're going to be in trouble because the calculator can only do what you tell it to do, and you won't always tell it correctly if you're not sure what's going on. And you also have to show your work, okay? Anytime I ask you to do something on your calculator, I will expect to, you know, that'll be understood. But otherwise, you've got to show me your work on paper. If it doesn't say, you know, use your calculator to solve this problem, then you need to do it on paper, and then you can use your calculator to check your answer, but I still need to see the work, okay? All right, so again, making sure you know how to use the viewing rectangle, what it looks like. And so one important aspect of a graph is what's known as the intercepts. Okay, so we go back to our picture here, right? Our intercepts are where you cross the x-axis, okay? So you cross the x-axis right here and right here. Those are called x-intercepts, and then the y-intercept is where you cross the y-axis, okay? So I'm going to do a little cool little thing here. I'm going to snip this out right here. All right, I'm going to snip this out, and I'm going to copy and paste it into our window. I'm going to give us an extra page here. And so here it is. I don't know what that thing is doing, that copy spot, but let me move this down a little bit. That's an interesting glitch. So anyhow, technology rocks. So anyhow, we've got these points right here, this point right here, and this point right here. This is called the x-intercepts because you cross the x-axis. This is called the y-intercept. All right, and so if these are each one unit, you can see that this happens at 2, 0 and at negative 2, 0. Those are your x-intercepts, and this is at 0, 4. So let me give you a little notation. Technically, intercepts are points. So the x-intercept, in this case, are 2, 0 and negative 2, 0. And the y-intercept, there's only one. Every function only has one at the most, is 0, 4, all right? But in my math lab and in the textbook sometimes, what they'll do is they'll ask for the non-zero coordinate. So the x-intercept technically happens when they happen at x equal plus or minus 2. And the y-intercept occurs at y equals 4. And so they only give you the one coordinate that's not 0, right? And so because they do that, I will accept that. But I want you to understand that when I say intercept, it's actually a whole point. All right, it is a point, so don't get that confused there. So here's another picture, example of what an intercept looks like for a straight line. Okay, here it crosses at 0, 5. It crosses at negative 3, 0. Okay, and so, and of course this line should have arrows on it telling you that it goes on forever, but whatever. All right, so that's how it works for intercepts, and intercepts are important when you're looking at your graphs. Okay, so the only thing left to think about is sometimes graphs represent real world issues. So here we've got D equals 4n plus 5. D is the percentage of marriages that end in divorce after n number of years. If the wife is under 18 at the time of marriage, this is just some sort of data that's been collected and they've modeled it as a linear model. All right, and so if you want to know the percentage of marriages that end in divorce after 15 years, if the wife is under 18 when she gets married, then you plug 15 in for n and you get 65. 65% of marriages end there. Now, that's, again, that's using a model. That's not necessarily fully accurate. I don't know what the data looks like, but that's just one way to use the model. And then if you graph it, there's your point. Okay, as you can see, eventually you're going to get to 100%, which doesn't make any sense. But that's how you kind of check your answer on the graph, by looking and see whether that graph goes through the point that you found. Okay, so that's one of the powerful things about graphing, is that it's a visual representation of a expression or an equation or a model. And a lot of us see things a little bit easier if we can see a picture of it, and that's really what graphing does. Graphing gives us a picture of the algebra, and that's why it's so important, and that's why we will interweave graphing throughout the semester. Okay, so that's the end of section 1.1. The homework for this will be very short and straightforward, just making sure you understand the Cartesian coordinate system, where points go, and that kind of thing. Okay, thanks a lot. See ya.